So we're given a whisker plot, and a whisker plot is essentially just a really efficient, effective way of communicating a data set while outlining very significant points within the data set. So we can play around up here, pick a different spread, pick a different data set, come up with a whole bunch of different examples, but we're going to stick with this one for the example. The first thing we want to look at is range, and essentially range is how far the entire data set spans. So you have your maximum point here. So within the data set, this is the largest number. This is your largest data point. This is the maximum. Your minimum is all the way on the left. This is the smallest number in the data set. So you can kind of line up and take a guess. You can kind of line up and take a guess, but thankfully we have the exact numbers over here. Our maximum is 107.6 and our minimum is 11.36. The range is really simple. It's just the max minus the min. So when you subtract the minimum from the maximum, you get 96.22, and that's the range, right? So then the next thing we can look at is the median. And the median is, we've got this box right here. It's this line going through the middle of the box. So the median essentially is the middle number. If you put all of the numbers in order, increasing to, or decreasing in either direction, the very middle number, that's the median. If there's not an exact middle, if there's a data set with an even number of points, you average the two middle ones, that's the median. It's just like in statistics. This median right here signifies that 50% of your data is on this side and 50% of your data is on this side. And in this case, our median is 59.02. We can look at the first quartile and the third quartile. And these are kind of like the median, but a little different. So instead of 50% on one side and 50% on the other side, we have 25 and 75. So this is your first quartile. It's the left side of the box. That means 25% of your data is less than the first quartile, and 75% of your data is greater than the first quartile. Now, don't get confused and think this must be 25% of the way to the end, and this must be 75% of the way to the end. There could be a whole lot of numbers in a smaller range and a few numbers in a larger range, or vice versa. So 25% of your data set is somewhere between 51.22 and whatever our minimum was. I think it was 11.36. And 75% is between 51.22 and whatever our maximum was. The third quartile is the right side of the box. So 25% of the data is on this side and 75% of the data is on this side. If you're talking percentiles, this is the 25th percentile, the 50th percentile, and the 75th percentile. The interquartile range is a lot like the regular range, except instead of going from minimum to maximum, we're going from first quartile to third quartile. So it's your middle 50% of the data. If you take your third quartile and subtract the first quartile, that's your interquartile range. So here we have 68.34 minus 51.22 equals 17.12. That's our interquartile range. So this comes in handy. Let's say you're given a question and they might give you two whisker plots. And they might say, find the difference between the medians, or find the difference between the interquartile ranges. What you'll have to do is you'll have to figure out, what's the median or the interquartile range for one, what's the median and interquartile range for the other. And it's good for comparing data sets. It's good for determining significant points within data sets. So they might say, what is the interquartile range of this data set? Or what is the difference between the minimums of the two data sets?